Okay. What does CRC stand for? CRC Error Detection System. What does CRC really stand for? It's just a side question. You don't have to answer it. You don't get what. Anybody know what CRC stands for?
Cyclic redundancy check.
Cyclic redundancy check. Cyclic, as in it will happen in cycles over the frame, over the data, and it will produce some redundant data that will be used to check the correctness of the frame. Right. CRC. What is the generator? What are the conditions required for the generator? Anybody knows? What do we mean by the generator first in CRC? Anybody knows what the generator is? Huh? The divisor, yeah, the value that's used in the kind of division, even though it's not really division as such, is it a division operation that happens in CRC? You know?
Yes.
It's an XOR operation. Okay. Right. This is the generator allocated to you. What's that in binary?
1, 0, 0, 1.
Yeah, thank you. 1, 0, 0, 1, 1. Yeah. And what's the condition? What are the two conditions required for the generator to be used successfully? You already know the conditions for a generator? It should be what? Less than the sender? What do you mean? Yeah, come on, you're there, but it's not quite with you. You're almost there. Okay, it needs to be shorter than the data. It has to be, like the data that you want to send has to be longer than the number of bits than the generator. Like you can't send 1 byte and your generator is 2 bytes. It will not work to do the data. The data has to be bigger than the generator. What's the other condition? It must end with a 1 and start with a 0? No, it starts with a 1. It must start with 1 and ends with 1. So both ones on either side. Okay, what else did we talk about? What is the advantage of CRC over parity? No, what's the advantage of parity error detection systems? Are you with us? Yeah, give me the advantage of parity error detection system. Is parity a good system or not? Parity error detection system, the parity bit. Okay. What's the advantage? Yeah.
Less redundancy used in parity. Only 1 bit of redundancy.
Say again?
Only 1 bit of redundancy used in parity while sending messages.
Only 1 bit is sent. Is that what you're saying?
Yeah.
And that's an advantage. So we send
very
little redundant data.
Yeah. Okay.
Yeah, it's okay. The error is in the other process now. I just need to see it so there. Thank you very much. Yeah. So, okay. Anybody? No, that's not a good. What's an advantage? I said, what's the advantage? And you tell me it only sends one bit. Yes, normally it would have been great if it only sends one bit. Is that correct answer? Okay, any other advantages? That's not the advantage, by the way. What's the advantage? How good is the parity system? Does it have any advantages? Did we do the parity system? Yeah. Okay, to give you a hint. How slow is it? Is it very slow? The parity system.
Doesn't have any delays.
It doesn't have any delay. It doesn't have any delay. Why not? Why is it fast? Because it uses logical operations. Anything that uses only logic, computers are extremely fast. With ANDing, ORing, NANDing, anything, comparing these two. But if we say add or divide or something, it's very slow. But logical operations are extremely fast. So that's one good advantage of parity error detection systems. What's the other advantage? Or is there another advantage? I don't know. I think I was asking for, okay, what about disadvantages? What's the issue with parity systems? I give you a hint, it's this bit that you send with every byte. It's not an advantage. Why is it a disadvantage?
It's only to take old number.
Say again?
It's only to take old number bits.
Alright, it can only detect errors. That's another disadvantage. It can only detect errors that are odd. Like it can detect 1 bit or 3 bits or 5. But it cannot detect what? It cannot detect what kind of errors cannot be detected by parity systems.
Or you stay with.
Or even bits.
Even bits.
Is that what you said?
I said that you cannot find for the odd bits. If odd bits flips, you cannot find.
If what?
Odd.
No, it will discover any odd number.
Also, not even. It won't discover even bits. Even bits flip. It won't discover.
It will not discover even bits that flip, like 2 bits or 4 bits or 6 bits or 8. Is that right?
Yeah.
Yeah, in a byte.
In a byte. You have to say in a byte, not in the message. Like it's 2 bits flip in the same byte, or 4 bits in the same byte, but not in the frame. So it's important to add the byte bit, the byte word, to say the problem is you cannot discover any even number of bits if they flip 2, 4, 6, or 8 in the same byte. And what's the other problem with parity? Why don't we use parity? Okay, it will not discover 100%. No error system discovers 100% errors. But what's the other problem? Yeah, it does not know where the error is. Even when it tells you there is an error in this byte, it doesn't tell you which bit. So you can't just fix it. You have to ask the sender to send the entire frame again, or message. Any other problems?
There's a lot of redundant data.
A lot of redundant data. We said it sends 1 bit with every byte, and you gave it as an advantage. In fact, that's not an advantage. Also, 1 bit is a lot.
It saves memory. Only 1 redundant data is sent because only 1 kind of.
Yeah, well, it sends 1 bit in a byte, but we never send a byte, we always send 4,000 bytes in every frame.
But in other error detecting, like in CRC or these kind of more than 1 bit of the data.
No.
1 byte.
How much does CRC send? How much redundant data does CRC generate? Anybody?
Less than generic.
Say again?
Less, 1 is less than generic.
Yeah, 1 bit less than the generator. And the generator is never more than 2 bytes. So that's in a frame. That's in 4,000 bytes, you're going to send 2 bytes. In parity, 1 bit in every byte. So if you have 4,000 bytes, you're going to send 4,000 bits, which is, quite a lot. If you send a file that's 7 million bytes, you have to send 1 million bytes of redundant data. With CRC, you send 2 bytes. So that's another problem with parity system, parity error detection systems. So parity error detection systems have the following problems. It cannot discover even bits. Errors that involve an even number of bits in the same byte cannot be discovered, full stop. And it cannot tell you which bit has the error, and also it has a very large redundant data. Right. If we had an error in Hamming code, did we do Hamming code? Error detection. The parities that are in Hamming code, what do we call them? Anybody remembers what we call them? We call them parity 1, parity 2, what else? 4 and 8, right? We don't call them parity 1, 2, 3, and 4. 1, 2, 4, 8, and 16, based on the position, their position. Right. If there was an error with parity number 1 group, we receive a frame and we divide, the different bits into their groups. So there's the parity 1 group, the bits that are associated with parity 2, parity 4, and parity 8. There's a problem with the group that represents parity 1 and the group that represents parity 2. Where is the error bit? Anybody? Where is the error? Thank you. If we have 2 groups, parity 1 and parity 2 groups, they are odd. When 4 and 8 are perfect, they're even. Where would the error be? Okay, so. No. How did we get 12? I said 1 and 2. So it's 1 plus 2. 1 plus 2. So it's the bit in position number 3. Now, if we get an error in parity bit group 8 and parity bit 1, where's the error? Where would the error be? If we got error in parity group, parity 1 group, had odd numbers, and parity 8 group had an odd number, where would the error be? 9. 1 plus 9. So guys, it's the parity numbers, add them up. If you had 3 groups with errors, 1, 2, and 8, where's the bit that has the error? 1 plus 2 plus 8. That's bit position 11. Okay, so whatever number of parity groups we have will determine, the ones that have errors will determine which bit needs to be flipped. And what's the problem with having code? What's the disadvantage of having code? I have the attendance switched on, so guys, get your mobile app and check in, please. I think, do I have it? No, I don't have it. What's the window size? What's meant by the window size in the flow control? Window size, definition of window size. What does window size mean? Yeah?
It indicates the number of frames extended on screen.
It indicates, so it might say send 2, it might say 6. Anybody can have a better definition? More accurate one. One word is missing, yeah?
If the windows are in this 3, then we have to take 0, 1, and 2.
No, okay, we're not talking about the sequence numbers. We're still just talking about what does the window size. If you're told the window size is 6, what does it mean? It doesn't mean you can send 6. It means the maximum frames you can send is 6. So the window size indicates the maximum number of unacknowledged frames. That's the definition. Maximum number of frames that you can send without getting an acknowledgement. If you get an acknowledgement, you keep sending. But the maximum of unacknowledged frames, so your definition was almost right. Just the maximum is the word that's needed. It's the maximum number of frames a sender can send without having to stop and wait for an acknowledgement. If you receive an acknowledgement, you keep going, as long as you do not exceed the maximum number. That's what the window size is. It doesn't say, hey, you can send 2. No, it's the maximum you can send. So you can send less. If the maximum is 6, then you can send 1 or 2 or 3 and stop if you like, but the maximum you can send is 6. Right. And if a frame is lost, who will discover it first? The sender or the receiver? The receiver. Almost correct, good answer. But sometimes the receiver will discover it first, sometimes the sender. Any idea who will discover a lost frame first? Give me an example. Right, I'll take your word, but give me an example that a receiver will discover a frame first.
Depends.
Yeah?
So a receiver is going to discover the frame first. The situation where the receiver has sent an acknowledgement.
Okay. And we're going to give you a little break. We'll come back to you, okay? Either making it up as you go along. Yeah?
You cannot see the screen.
You cannot see the screen. Okay, no, I don't. Yeah. I intentionally have it hidden until I finish asking the questions. Then I'll let you go on. What was the question? The question, right, okay, let me ask you another question. I send you frames, you're the receiver. I send you frame 1, 2, 3, 4, but one of the frames got lost. Which frame, and you discovered it. How would you discover if one of the frames is missing? Maybe if you only get 1, 2, yeah, but what if frame number 4 is lost? How would you, or how could this lost frame be discovered? The window size is 4, I send you, for example, and halfway through we will send you 1, 2, 3, 4. But number 4 you never received, got lost along the way. Hold on, I'll get back to you. Anybody, how will this lost frame be discovered? Right, yeah?
With timer.
The timer, which timer? The sender's timer or the receiver timer?
The sender, when it's sent a frame, just blind it, and if he doesn't receive the checksum.
Yeah, the receiver will not. Yeah, the receiver will not know that the frame is lost. Normally, what will happen? The receiver finds 1, 2, and 3. Let's say number 4 never arrived. So normally, when the receiver has no more coming frames, we'll say, okay, let me send an acknowledgement. So I'll send to the sender and say, I've received number 3, and I'll make it number 4. So that's normal operation. But if the receiver does not send an acknowledgement, the sender will have a timer that will go off. So, but in this case, actually, the receiver will send an acknowledgement. If I receive frames 1, 2, and 3, and they don't receive number 4, that's okay. Maybe that's all there is data. Maybe the file is finished, the transfer is finished. So, when there's no more, normally, the receiver doesn't send an acknowledgement after every frame it receives. The sender has to send the maximum window size. Let's say, for example, now 4. So the sender has to send 4. But what if it just finished the data? There's no more data to send. So it'll just send 2 and stop. So as far as I'm concerned, the receiver, as long as there are frames, I process them. When there are no more frames coming in, I say, all right, let me notify the sender. So after receiving frame 1, 2, and 3, and 4 is lost. Maybe there's no frame number 4. As far as I'm concerned, I don't know if there is a frame or not. But I've received 3, and there's nothing else coming in the queue. I can now send an acknowledgement to the sender. And I tell the sender, I've received frame 1, 2, and 3. What acknowledgement, what number will I put in the acknowledgement to tell the sender that we've received frame 1, 2, and 3?
The last one that I received.
Acknowledgement 3. Do you agree with her? What acknowledgement will you send the sender if you receive frame 1, 2, and 3? You want to tell them, I have received frame 1, 2, and 3. Acknowledgement 4. You have to say acknowledgement 4. What does acknowledgement 4 mean? If you're the sender and you receive from me, you sent me a few frames and I sent you acknowledgement 4. What does it mean?
Sender will start acknowledge not
Yeah. No. Acknowledgement 4, what does it mean? If you receive acknowledgement 4, what does it mean to you? Any ideas? Yeah.
It signifies no errors detected.
Okay. But that's not enough. In what? In all 4 frames?
Yeah.
I only received 3. Oh, I don't know what I received. No.
For example, if the sender get the
Acknowledgement 4. You got acknowledgement 4.
Yeah.
What does it mean? You're the sender.
sender is stop with the 1, 2, 3, 2, stop with the 1 to locate 2, 3 to locate, so the stop with type.
Okay.
It means that it's waiting for the acknowledgement 4.
Yeah.
Just send it.
Acknowledgement 4 means I have received up until the one before number 4. I did not receive number 4, so it's an acknowledgement with any number always acknowledges the one before that number, not that number. And it also means this is the number I'm waiting for now. I'm waiting for number 4. So if I send you acknowledgement 7, what does it mean? It means you received up until number 6, you have them perfect, and you're waiting for number 7. That's what an acknowledgement means. Always. It has at least those 2 meanings. It has other meanings, but these are 2 so far that we covered. Anytime you receive an acknowledgement with any number, acknowledgement 22 means you did not receive 22, you expect to receive 22, but you've received up until number 21. So the acknowledgement always means you've received the one before that acknowledgement number, and you're waiting for the next, that's the number that's mentioned in the acknowledgement, and that's the one you expect to receive next. You did something else. Right. Now you sent me frames 1, 2, 3, and 4, and I want to send you acknowledgement. I received all the 4 frames. What acknowledgement number will I send you? 5. 4 means I did not receive 4. 5 means I received 1, 2, 3, and 4, and I'm waiting for number 5. Okay? But the acknowledgement I sent you got lost along the way. You didn't get it. So, what happens in our communication? You cannot send me anymore until you receive acknowledgement. I've sent you acknowledgement, the acknowledgement got lost. How do we proceed?
Time is over.
So what?
Time is over.
When the timer is over. Which timer? What timer? Any idea which timer? Okay. I forgot that question as well. The question is, I sent you sent me frames 1, 2, 3, 4, and I sent you acknowledgement 5 to indicate that I received 1, 2, 3, and 4, and then waiting on number 5. That's what acknowledgement 5 means. But along the way, this acknowledgement 5 got lost. You never got it. So how are we going to continue to communicate? Because you're not going to send me any more until I send you the acknowledgement. And I sent you the acknowledgement, I'm not expected to send it again.
The only way to know is if the sender has a assignment, that's each frame.
Yeah,
Doesn't receive the acknowledgement, but you send
yeah,
everything in.
exactly. So every time the sender sends a frame, and those 4 or 5 frames that the sender has sent, every time he sends one frame, he starts a timer. So if the acknowledgement is lost, and I'm sitting waiting for number 5, but the sender is never going to send number 5 because he never received my acknowledgement, but there's something else that's ticking. It's the timer that the sender sets up for every frame they send. So, for example, they set it at 23 or 25 million for the second, so after 25 million per second, the timer will go up, and that will be an indication to the sender to say, hey, something went wrong. Maybe the frames you sent were lost, or the acknowledgement was lost. Send them again, send those frames again. So that's the mechanism that they have in retransmitting those frames. If a frame got lost. So guys, either what happens if you send me frame 1, 2, 3, 4, like you've sent me 4 frames, but number 3 got lost. How do we solve that problem? Any idea?
Should I keep a copy of that?
What?
Should I keep a copy of that?
Repeat it slowly, please.
Should I keep a copy of that?
Yeah, I know that, yeah. But how does the sender know it's lost? I'm the receiver, and I got frame. You sent me 4 frames, but number 3 is lost. It's not there. So I got 1, 2, and 4.
It sends that acknowledgement number 3, and and the sender sends
Why would
three
I
for
send
again.
acknowledgement 3?
Because,
I got number 4.
yeah, but the 3 is missing, so they'll send it again.
Okay, so the receiver will receive frame number 4 instead of 3. If I was the receiver, I got 1, I'm waiting on 2. I got 2, I'm waiting on 3. 3 never got there. I got 4. So I say this is called out of sequence. So if the receiver receives a frame out of sequence, not in the right sequence, instead of number 3, I got number 4, then that's when the receiver discovers, there's a missing frame. That's when the receiver has to send an acknowledgement to the sender. Now, what acknowledgement number will the receiver send to the sender? How does the receiver tell the sender, hey, number 3 is lost? You tell him by sending an acknowledgement. What acknowledgement number? Number 3, the missing one, the one I did not get. The number, what an acknowledgement 3 means, I got everything before 3, and I'm waiting for this one, number 3. So always, this is always the rules about acknowledgement. If a missing frame, you send that acknowledgement to that missing frame, if you've received everything before it. So I've received 1 and 2, and I'm waiting on number 3, I got number 4, I'm still waiting on number 3, I send you acknowledgement 3. That means I got 1 and 2, received them, and I'm waiting on number 3. And what do I do with number 4 that I got? I got number 4. What shall I do with it? I got number 4. I know it's an error, but I should have got number 3. It's out of sequence error. So what do? I sent an acknowledgement.
Discard it.
Pardon?
Discard it.
Discard it. Throw it away. You don't keep it. You don't keep out of sequence frame. Even if it's perfect, there's nothing wrong with it. But what's wrong with it, it's out of sequence. Out of sequence frame. What happened with this attendance thing? Oh. Password is wrong. Like this. Okay, we got into the attendance thing, so maybe I'll just show you what I have at the moment. And what time is it now, guys? This is Tuesday, 2 o'clock, right? 2 till 5. And I better start taking the attendance. So. What does modulo 128 mean? Modulo 8 or modulo 128? What does it mean or indicate? Come on, guys, I thought I mentioned this, talked about this last time. Anybody? Yep.
From our understanding, it means use of 7 numbers from 0 to 7.
Yeah. So the modulo indicates what sequence numbers to use. You either use the numbers 0 to 7 and recycle after 7, or if it's modulo 1 to 8, you use from 0 to 127, and when you go past 127, page number or packet number, you go back to 0. You recycle the numbers. So the modulo indicates whether what sequence numbers to use. Okay, the attendance, I'll leave it now. Remind me to save it later on, please. Okay, let's go back to, I don't know here. What does go back in mean? It's a protocol. What is the problem that's solved by the sliding window protocol? Why do we use this go back sliding window protocol. Why is it used? To solve error detection? No, CRC is used to do that. What is the problem solved by using this that we're talking about? Send me frame 5 frames, send you acknowledgement 6, send me 6, 7, 0, and so on. To solve the flow control problem. Now, what's the flow control problem? Any idea what the flow control problem is? Why do we need to solve this problem? What is this problem? It's a problem if we have a fast sending machine and a slow receiving machine. If you have two neighbors connected together and they're sending data, the sender is sending data to the receiver, but the sender is powerful machine, fast machine, big CPU, and lots of memory, and the receiver is really slow. So if you send things so fast, when the receiver receives a frame, it needs to process it immediately. And it starts processing. But if another frame arrives while it's still processing the previous frame, then it say put it in memory. I'll deal with it in a minute, a second, a couple of minutes. But maybe more frames arrive. So put them in memory. After, if this is really slow, this receiver, then the memory might even fill up. So anymore, you can't process it, you can't store it in memory. You throw it away, you discard it. And then that's the problem, just gets worse. So the two machines, and there's no guarantee that your neighboring computer in a network is a machine that's at your caliber. It could be a lot slower or faster than you. So then the flow, this sliding window protocol that we're talking about, its main purpose is to solve the problem of flow control, the flow control problem. So what it does, it actually slows down the fast sender, but if the sender is the slower one, it will not slow it. It will let it continue slow it. It will allow it without any limitations. So it only comes into action if the sender is slow, if the sender is really fast. Okay, so that's really the main purpose of the sliding window protocol that we talked about. Right, I'll just remind you guys briefly of the first protocol that we talked about, and it's called the go back in. Pardon? Are you talking to me? Yeah? Yeah. Is that too bright? Will I darken it a bit, or are you all right? Bright, darker, brighter. Yeah. Is that okay? Maybe I'll use a black. Anybody has a black or red? Yes, sir. I forgot to bring it. It's on my desk. I have one of yours. No. Listen, I don't want to end up with everybody's file.
Which pen you need?
It's just, I'm saying it because last week I ended up going back with 2 of your biros, guys. I have them at my desk. I'll bring them next week. So this is probably slightly better. Right, go back in. Go back in means the receiver will occasionally slow down the sender, and sometimes if a frame is lost, we say no, go back to that number and start transmitting again. That's what go back n as in number of a frame. So normally we need a modulo. Let's say we use the modulo 8. What does modulo 8 mean? We said earlier on, what does modulo 8 mean? we recycle the numbers from 0 to 7. Modulo 8 means we use 8 numbers. 0, 1, 2, 3, 4, 5, 6, 7. That's 8 numbers. And then recycle, go back to 0 again. So just on a line of numbers, if for example we start sending frame number 0, 1, 2, 3, 4, 5, 6, 7, and then the next one is going to be 0, 1, 2, 3, and so on, 4, 5, 6, 7, and then 0, 1, 2, 3. So these are the sequence numbers that the sender must send. And usually the sender, every time it sends, it always has a pointer called the next number I'm going to use. So when we start everything, when we initialize and the computer switched on, the sender has something pointing at number 0. We haven't even sent a frame, but that's the next frame. It's called the next frame number to send. So the next frame I sent, I'm going to give it that number 0. So it has a variable, NS or next to send or whatever you call it. I'm just going to have pointing at it. So the sender has a number that always points at the next sequence number I'm going to use. If I send a frame, I'm going to give it number 0. And if I use it, I'll push the pointer to the next number. So let's say, for argument's sake, we have window size 3, for example, or 5. We agree window size equals 5. What does window size 5 mean? Were you here earlier? Or are you getting late? What does window size, you're not with us. What does window size 5 mean? Anything? What do you think? Yeah. What's the definition of window size? Okay? I can't hear you. What does window size 5 mean? When we say window size, what does it mean? The number of frames that the sender can send. It's missing that one word. The maximum number of frames that the sender can send. Guys, it's okay. I'm just pushing these questions and with the hope that you remember in the exam this word, the maximum. If you don't write the maximum, we don't get the full mark of the question. But anyway, so the window size 5. What does window size 5 mean again? What does window 5 mean? Window size equals 5. What does it mean?
The maximum
is 5. So the maximum number of frames that the sender can send is 5. Provided you have lots of data, keep sending. But send 5 frames and stop. You can't send any more than 5. That's what the window size 5 means. Right, and the numbers we give it. So every time this guy sends a frame, you give it number 0 and it will push the pointer to the next one. That means the next frame I send, I give it to number 1. So when it sends 5, the next number is going to be pointing at 0, 1, 2, 3, 4. The next number is going to be pointing at 5. Why? Because it sent 5 frames. 0, 1, 2, 3, and 4. And it has to stop. Why? Because the window size is 5. It means that's the maximum number of frames you can send. 5 frames. But that's 4. Yeah, but that's starting at 0. That's a total of 5 frames. And the sender has this variable. It's something, the next number I'll be sending is 5. So if it's to send one more frame, it will give it number 5. And always, every time it sends a frame, to increment that number. So now the pointer is pointing at number 5. So the next frame it's going to send is going to be number 5. Right, what else does the sender do? If you're asked to describe this, go back in. The first thing you say, the sender and the receiver agree on a window size. For example, here 5. They also agree on a modulo. And now, for an example, 8. Now, when the sender sends, it will send, we assume that there's lots of data available to send. So, the sender will send 5 frames, and the exact numbers that are sent, starting from 0, always start at frame number 0. 0, 1, 2, 3, 4, and must stop. Now, something else. in this system that every time the sender sends a frame, must keep a copy of that frame. So it actually will keep in its memory frame number 0, frame number 1, 2, 3, and 4. Anything else it needs to do? Anything else that the sender must do? What else does the sender have to do, just in case these frames get lost? Timers. So the sender must start T0 timer, an alarm set, timer for 0, timer for 1, timer for 2, timer for 3, and timer for 4. What's the timer? The timer is you set an alarm to go off. So if you send a frame, two things can happen. Either you're going to receive an acknowledgement, which you go and turn the timer off, or if the frame is lost or the acknowledgement is lost, the timer will go off. So the timer has to be not short. It has to be longer than the time you send the frame, the other machine to process it and send you back the acknowledgement, and then maybe double that or triple that. Okay, so normally in a network, when you join a network, they tell the programmer, listen, our read transmission timer is 30 milliseconds or something like that. So you normally stick to that. Yeah?
Can you repeat the timer part, like why do you use timer?
Okay, well I said I was explaining how go back in works. The sender and receiver agree on a window size. They agree on the modulo. The sender starts sending frames based on the window size. In this case, window size 5, that means you must send 5 frames starting at number 0. First frame you always send is number 0. But that's just the first one you send, and then, it could be 2 hours later we send millions or billions of frames, but they're still between 0 and 7. Now, we send 0, 1, 2, 3, 4, and the sender stops. And when the frames are sent, the sender keeps a copy of each of those 5 frames and sets a timer for each frame. Every frame sent, you send it and stop the timer. Send it and stop the timer. And the purpose of the timer, just in case the frame is lost, the timer will go off. Because, for example, if the 5 frames are lost, 5 frames never got to the receiver. So the receiver is not going to send you an acknowledgement for nothing if it got nothing. It's just going to, the receiver is asleep, waiting on some information to come in. If it got nothing, for some reason the network lost it, then these timers will start going off. The timers are like the timer you set when you want to wake up in the morning. Let's say you want to wake up at 7 o'clock. A few people with you in the room, so you set the timer. But you wake up at 5:30. So what you do, you go and switch the timer off. So it won't go off. So this timer is set off. It will go off, but if the receiver receives those 5 frames and sends us back an acknowledgement, first thing we go and do is turn off the timer. So anytime the sender sends a frame, there are either of 2 events can happen. Either you receive an acknowledgement, or the timer will go off. One of them. Definitely. Anytime you send a frame or a group of frames, you're either going to receive an acknowledgement back from the receiver, or if you don't receive the acknowledgement for some reason, maybe the acknowledgement is lost, or the frame you sent is lost, then the timer will go off. The alarm will go off. If the alarm goes off, now let's leave it, we'll see what happens now if the alarm goes off in a second. So let's just take one normal processing and then we get down to the errors. So the receiver here receives 0, 1, 2, 3, and 4, and checks each one of them in sequence. It starts with number 0, checks it for errors. It's good. Number 1 is good. If it's good, it will send it upward to the network layer, to the transport layer, go to the user. So we say we forward it to our user, whoever the user is. That's the higher level. We only forward to the user the frames that are in the right sequence. Imagine you are the user and you sit in your laptop and you're watching a video. you want to watch the video in the correct sequence. So if your number 3 is missing, don't send me number 4. So that's the way this system works. So number 0 is the correct one? Yes, perfect. The receiver also keeps what is the next frame I'm expecting to receive. When it starts first, the next frame to receive is number 0. So I've got number 0, I'm perfect, send it to my user and increment this. So now I am waiting for number 1. I check the next frame. Is it number 1? Yeah, good. Send it to my receiver and I'm waiting for number 2. Increment the next frame you expect to receive. Until, for example, you receive 2, 3, and 4, now you're waiting number 5. There's no more, nothing in the incoming line, there's nothing in the queue. So we finished, we received everything that was coming down, those 5 frames were received. So now we're waiting for number 5. So when there's nothing else left, we send back one acknowledgement. So we send an acknowledgement, and the acknowledgement number, if I receive frame 0, 1, 2, 3, and 4, what acknowledgement number will I send back? 5. Very good, okay. Thank you guys, I got a real positive 5 this time, I'm happy. Right, so we get an acknowledgement 5. We send back an acknowledgement 5. That means, what does acknowledgement 5 mean? Now, the sender sent 5 frames, 0, 1, 2, 3, and 4, and the receiver sent back acknowledgement 5. What does acknowledgement 5 mean? I'm waiting for frame number 5. What else could the acknowledgement mean?
It means that the frame that is cleared, the receiver receives this object and now it's waiting for the next one.
Okay, what number is the next one? Number 5.
Yeah.
Right, so acknowledgement 5 means I've received everything before 5. That means I've received 1, 2, and 3, and 4. And I'm waiting for number 5. That's what the acknowledgement means. So this is what the sender is waiting for. Acknowledgement 5. So the acknowledgement, the sender already has those copies of those frames. When it receives acknowledgement 5, that means our receiver has received all those 4 frames. 0, 1, 2, 3, and 4, the 5 frames. That means there's no need to keep them anymore. They've already been acknowledged to us. So first thing, the sender will go and delete. First, we'll turn off all the timers and delete all the copies that were kept. Because no need to keep them. We keep them just in case they get lost. But now we know, we have confirmation that they have been fully received, and maybe the user is even watching them out at the other end. So now, we delete them, we empty our memory, the memory that's allocated to the data link layer on the sender machine, and now we can send the rest of the file. So we make more frames, or packets, or whatever they are, and send few more frames. What are the frame numbers that the sender will send now?
5, 6, 7.
Hold on, I have a volunteer here. Yeah? Frame number 5? What else? So send frame number 5, and what's the next number? Thank you, 6. And then what's the next number? 7, thank you. And what's the next number? Did you say 8?
0.
Oh, 0, yeah. No, I thought you were going to say 8. Okay, and 1, I guess. Right. So we send the next frames. And number 2, shall we send number 2 as well? We send 5, 6, 7, 0, 1, and 2, or not? Why not? Because the window size is 5. That means you cannot send more than 5. That's the maximum number you can send. So we send 1, 2, 3, 4, 5. Starting from number 5, 6, 7, 0, and 1. Right. I need you to go really smooth with this. What else would the sender do as well as keeping copies of those frames? Any idea? Anything to do with the timer? What do you think? It starts a timer for every packet or every frame here. So start a timer for number 5, a timer for number 6, and a timer for each one of those until timer number 1. And sends them this way. So 5, 6, 7, 0, and 1. 5 frames. Right, and this guy gets them, so they start checking them. 5, 6, 7, 0, and 1. But now, let's say 5 is perfect, 6 is perfect, but 7 has got something wrong with it. And 0 is good, but 1 is also. There's an error with number 7 and number 1. So what happens? Who wants to take it from there? What happens to the sender? I need the others to think about it. Come on, guys. Who's going to help me out there? At the very end there? The back row?
There's an error.
Are you talking to me? Yeah.
There's an error. Where's the error here?
Frame number 5 is perfect. Frame number 6 is perfect. 7 has an error and 1 has an error.
So it's where you said, I'm acknowledging 7.
Good. So let's start with number 5. What happens to number 5?
5 gets passed.
Number 5 is perfect and it's in the correct sequence. We'll send it to our user. Right. What about number 6? So I'll just write here U. 6 also goes to the user. Number 7.
Yeah, number 7. If I have number 7 is not there, number 7 acknowledgement have number 7.
There's something wrong with number 7. What do we do with it? Do we send it to our user upstairs? Discard. So we're gonna discard this. And what do we do? We go to the next frame. We send back an acknowledgement. What acknowledgement number should we send back?
7.
Why 7? What does acknowledgement 7 mean? Not you, thank you. What does acknowledgement 7 mean?
It means that it's correct.
It means it's correct or not correct.
So when it acknowledges 7, at that point, because it's getting back.
What does acknowledgement N mean? Acknowledgement 7. What does acknowledgement 5 mean?
Acknowledgement 5 means the other person received it.
What does acknowledgement 7 mean?
It means like the 5 and 6 goes like properly and.
It means we received number 6, not 7. The one before the acknowledgement, not 7. You say acknowledgement 5 means we received 5, not we received 4. Now in this case, it's number 7. Okay, excellent. Caboose, guys.
This is why it's making noise.
You know, I come from big job. It's caboose.
Yeah, he can understand his but why is that?
Okay. So, acknowledgement 7, what does it mean?
It means like it completes the like 5 and 6, it says properly and then stop at the 7. That's why it says.
And we expect to receive number 7 from you. So acknowledgement always means 2 things at least. Number 6 is okay, and we are waiting for number 7. Send us number 7 now. That's what it means. Okay, so it goes there, but we sent it, but this guy still has a lot of packets coming in the incoming line. So we still have 2 more packets. Now the next packet is number 0. Looks at number 0, checks it, it's perfect. What does it do with it? What do you think? We got packet number 0 now, the receiver. See, the receiver got 5 is correct, 6 is correct, 7 has an error, we sent an acknowledgement to the sender, but immediately we got another frame, number 0. What do we do with frame number 0? We check it, it's perfect, there is no error with it. Discard is what? Why discard? It's out of sequence. Why? Because we are waiting on number 7. See here, we're waiting on number 7, it has a problem. We're still waiting on number 7, we got number 0. That's an error. That's called out of sequence error. And what do we do with out of sequence errors? Discard. So we discard the frame, even though it's a good frame that had no errors, but we still discard it. And then we look into we look in this here and we find frame number 1. Whether it's good or bad, it has frame number 1, we discard it because it's the wrong sequence number, it's out of sequence.
So why we are looking for others?
Pardon?
Why we are looking for others and
It
already discovered at 7 there is an error. So why would we go, why receive a score for
You can send also another acknowledgement 7 if you find another error. But as we've already sent an acknowledgement and we're waiting on that. But you know, in some it depends on the application. Some applications, every time they find an error, like this one, this is out of sequence error, they might fire another acknowledgement 7. And this one here, it's also out of sequence, or might even have parity bit error with it, or CRC error. It will send another acknowledgement 7. Anyway, so this guy does not send to its user anymore. But these 3 get discarded. Now the sender gets acknowledgement 7. What does the sender do with an acknowledgement? What does the acknowledgement, how does it help the sender? Anybody?
Yeah.
Not you, no. Give us a chance now. What does the acknowledgement 7 do? Well, the receiver is waiting on some acknowledgement. It's probably, it said 5, 6, 7, 0, and 1. Got acknowledgement 7. What does it mean? It means it received number, what did he say?
7.
Acknowledgement 7, guys, I hear an answer. So this guy says, when you receive acknowledgement 7, that means go back and send number 7. But before you send number 7, acknowledgement 7, it acknowledges what? It tells the sender, we have received some frames. What are the frame numbers that have been received correctly? 5 and 6. Anything below 7. So, first it goes and turn off those 2 timers, 5 and 6, and clear the memory. Remove some of its memory. So now, it can send, and that's what it should send back. So it sends 7, what else should it send?
0, 1.
7, 0, and 1, right? Pardon? 2 and 3. Why 2 and 3? Because the window size is 5. So it sends 7, 0, 1, 2, and 3 and keeps copies of those frames. And what else? Don't forget the timers. Every time the sender sends a frame in this sliding window protocol, it must keep a copy of that frame and it must start a new timer for that frame. So it sends copies of frame number 6, 7, 0, 1, 2, 3, and timer T7, timer for frame 0, timer for 1, timer for 2, and timer for 3. And what's the function of these timers? Why do we set these timers? What's the purpose of setting those timers? If no acknowledgement is received, we can retransmit them. We know the frame got lost or the acknowledgement got lost, and that will allow us the system to continue. Now this guy sends frames 7, 0, 1, 2, and 3. And this time we've received them all, 7, 0, 1, 2, and 3 without any errors. What does the receiver do? What does the receiver do with frame number 7? Pardon? Hold on. What do we do with frame 7? So this goes to the high-end user, and 0 to the user, 1 goes to the user, they all go to the user in the right sequence. And we send back acknowledgement. Acknowledgement 4. Just one second, I have a question. What does acknowledgement 4 mean?
So after it will 4 means that's 5 or 3 are the same. All of them.
If you receive acknowledgement 4 and the sender has already sent us few frames for these, we've received everything before 4. That means up to number 3 is Those frames 7, 0, 1, 2, and 3 have been received and acknowledged. And we received it correctly, and that's what we expect to receive from the next in number 4. In the comment, we acknowledge what's involved. Okay, that's all I give.
It's 1, 5, 6, 7, 0, 1 is sent and equals 7 is the error, but it's the acknowledged 7 not received by the sender.
Number 7.
Yes.
Yeah, we send back acknowledgement. That's what we had here. We had an error with it. But maybe if we had not received it at all, then we would receive number 0. But we were waiting on number 7. That would be the wrong sequence number. So after sequence 0. Okay, yeah. Okay. If this is lost, we had it before the timer seal started going off. We do it now. We do it now. Yeah, we do it now. We do that example now. Okay, guys. Here's the question now. Another question or so? Yeah.
For example,
I can't hear you. I can't hear you. Please be quiet, guys. Yeah.
when the receiver sends acknowledgement message
4. Yeah.
this is the message to log.
If it's lost, that's the same question, but we'll do it now. Right, now, the sender sent, after acknowledgement 7, we sent 7, 0, 1, 2, 3. They're all received perfectly, and we pass them to our user, and we are waiting now for number 4. So we send acknowledgement 4. Acknowledgement 4, guys, means 2 things. We're trying to tell the sender that we've received up until number 3 perfectly. So it acknowledges the one before this number. And we are also telling the sender that's what we expect to receive from you is number 4 next. But number 4 does not make it. And let's say number 4 had a problem, got lost. So this acknowledgement is lost. Is that the question? And your question, right? So this guy is waiting to receive an acknowledgement for 7, 0, 1, 2, and 3. Excuse me, the acknowledgement was sent, but it was never received. It was lost. So what happens here?
Send again all those frames.
Yeah. What do you think? Yeah, so this guy, the sender, every time it sends a group of frames, it goes to sleep, waiting on 2 events to happen, either of 2 events. Do you know what the 2 events are?
Either to receive acknowledgement or for the timer to go off.
Yeah, either we're waiting for acknowledgement number 4 to arrive, or the timers will start going off. Now, if the acknowledgement is lost, excuse me, the acknowledgement should have been received after maybe 10 millionths of a second, but the timers will be set maybe for 30 millionths of a second. So we're waiting for 10 millionths, this got lost, 11 million, 20 million, 30 million, then the timers will start going on. So the first timer will go off is timer number 7. So the timer will go off, now the sender will wake up and say, oh, timer number 7. This is called the retransmission timer. That means every time this timer goes off, retransmits that frame. So it takes number 7 and fires it off and restarts the timer again. It's like you want to cook something and you put the timer, but it didn't cook, so restart the timer and put it in the oven again. So number 7 is sent, and you start the timer again. And then immediately after that, timer number 0 will go off. So the sender will send number 0 and restart the timer. And then eventually number 1 will go off, 2 and 3. So it's basically, it will send the same copies of the same frames again. But those frames were already sent and were already received. So what happens next? What happens now? We've already received. Sorry. My time has come back. Remember this here, we've sent frame number 701, 2, and 3, and we sent acknowledgement. But the acknowledgement got lost. So this guy sends them again, 701, 2, and 3. But they were already received, and they were already given to our user. So what happens? What does the receiver do? Any idea?
Like it received the acknowledgement is missing now.
The receiver is waiting for frame number 4.
Yeah.
But it's not. It's got 701, 2, and 3. Anybody? What do you think? Yeah?
So I think based on the fact that it's not receiving the number after 4.
The receiver is waiting for it to receive an acknowledged frame 0, 1, 2, and 3 and pass them to our user. So our user is watching this video. What's the next frame it's waiting for? It's waiting for number 4.
Yeah.
But it got number 7. So what happens?
Yes, it's waiting for that. There's an error.
Send again acknowledgement.
So it will say, that's not the one I'm waiting for. I'm waiting on number 4. Remember, there's something, a variable always called the next frame to receive. So now we're waiting on frame number 4, but we got number 7. That's the wrong sequence number. So out of sequence. So discard. So we got 7, discard it. We got 0, discard. We got 1, 2, and 3, discard them all. Anytime you get, these are called duplicate copies. Well, if we got it before, we shouldn't be keeping it again. At least we might get it, but we don't send it to our user. Like if you're watching a video, you don't want to get the next frame, 5 frames again, watch them again. Or if you're downloading a file, you don't want to put 5 pages twice in that file. They've already been received. Discard them, and when you've received number 3 at the last one, and there's no more frames to send, you send now acknowledgement. What acknowledgement do you send? 4. You say, listen guys, and we're waiting on frame number 4. We've already received up to number 3. We've discarded all these. Hopefully, this time the acknowledgement doesn't get lost. It will get to the user, to the sender, and the sender will say, you're waiting for number 4. That means number 7 is, I no longer have to keep those copies 7, 0, 1, 2, and 3. Turn the timers off first, clear the memory, and send number 4, 5, and so on. So this guy here will discard all these frames, reset all the timers, turn them off, and send number 4. What frame numbers will the sender send? Okay. What frame numbers will the sender send?
4, 5, 6, 7, 0.
And 1. Why stop at 0? 1? No, there's a lot more data to send. Why stop at 0?
Frame size, the window size.
The window size is 5. That's the maximum number of frames unacknowledged that can be sent. Okay, so this is the way the go back in works. Right. Next question. If we have, for example, if we were using modulo 128, what does that mean? That means we can send 128 frames, maximum number of frames that the sender can send without acknowledgement. But does the receiver need memory for that? Who needs memory? The sender or the receiver, or both? Can we pick 100? If we say window size 100, is that critical to the sender or to the receiver? Or to both? What do you think? Why? What about the receiver?
It's a both, sir.
Pardon?
It's a both.
Well, the receiver, as you noticed here, at the data link layer, not the physical layer where information is received, but the data link layer, the sender has to keep copies of all frames until they are acknowledged. The receiver doesn't have to keep any copies. Every frame it receives, it's either good, send it to my user, or bad, discard it. I don't need to keep any frame. If they were kept at the incoming line, that's at the physical layer in general memory, but not at the data link layer. At the data link layer, the receiver takes one frame and look at it. It's either the correct, it's a good frame, and it's the right sequence, and I send it to my user. Or it's a bad frame, or a wrong sequence, gets it discarded immediately. So there is no memory requirement on the receiver machine to have more memory. Only needs space for one frame to process it, bring it in. Is it a good frame? Yes, send it to my user, finish with it. Is it a bad frame? Discard it. But the sender, does the sender, if we say window size is 100, does it affect the sender? How much memory does the sender need to have? We know the receiver, maybe it doesn't need any memory. It needs one space for one frame to process it. Good, send it to my user, bad, discard. What about the sender? The sender must have enough frames to keep whatever the agreed window size. So in this case, we said window size 5, the sender must be able to keep in memory, in the data link layer, in all those 5 frames. So whatever the maximum frame size, multiplied by the window size, that's as much memory as the sender needs. So it's more the window size. If we agree, if we negotiate, we say, can we go for window size 100? Who needs to decide? The sender, because the receiver doesn't make any difference to the receiver whether the window size is 2 or 1,000. It doesn't make it. Get one frame, if it's good, send it up to my user. If it's bad, discard it. They don't need to save any frames. But the sender must be able to save all the frames until they are acknowledged in this sliding window protocol. This is the go back N. And why do they call it go back N? Because remember here, like in this example, when the sender sent frame 5, sent frame 5, 6, 7, 0. Where is it? There it is, 5, 6. Now let me go back to the other one. It sent frame 7, 0, 1, 2, 3. So when the sender sent those frames, 7, 0, 1, 2, and 3, and it's waiting to send number 4. The next frame is going to send is number 4. But it got an acknowledgement. 7, 0. But it didn't get the acknowledgement in this case. No, for example, if there was something wrong with number 1, then we'd have sent it acknowledgement 1. So we say, it's like when you send an acknowledgement 1 to the sender, it's like, don't send whatever you're going to send, go back to number 1 and start sending again. So that's why they call this go back in. So the sender is always wanting to send the next frame, but sometimes we send it back and we say, hey, go back to number 2 or number 7 and retransmit it again, start sending from that onward. You can't just go back to number 3, send number 3 and come back again. Once you go back to number 3, you have to send 3, 4, 5, 6, and so you have to go back and retransmit all the frames starting from this acknowledgement number. But anyway, so which one needs more memory? Which one memory is more critical? Is it the sender or the receiver? It's the sender. The sender is the one that needs to decide, hey, can we go for window size 50 or not? The receiver, it doesn't bother the receiver. It's only the sender that needs to keep the copies of those 50 frames. If it has enough memory, we go ahead with it. If it doesn't, well then the sender cannot continue. Right, so this is called the go back in. And this is the most used sliding window protocol in all the network. And what's the purpose for using the sliding window protocol? What's the main purpose for using this sliding window protocol? I asked this question earlier on, guys. What's the purpose for use of the sliding window protocol? Is it to solve the error detection problems? The flow control problems. And you know what the flow control problem is? What's the flow control problem? If we have a faster sender and a slower receiver, then we're going to have that's a flow control problem. So the flow control problem only happens if we have a faster sender and a slower receiver. Okay, so what's wrong with this system? I'm going to give you another example. We're going to have modulo 128. And we got window size equals 100. So here's the sender and here's the receiver. Who's going to start telling us what happens? What's step number one? We have window size 100. We have modulo 128. We're going to start. So what happens? What's the first step that happens now? The sender is sending. What will the sender send?
100.
Yeah. What numbers are they?
0, 1, 2.
Okay, so 0, 1, 2, all the way to 99. Perfect. So it might take a few seconds maybe. They could be 4,000 bytes each. So we're sending 100 frames. And we have no problem, no issue, because the sender has lots of memory. That takes some time to transmit them all. And they were all received, guys, from 0, 1, 2, 3, all the way to 98, 99. 100 frames. They're all received perfectly correctly, except number 0. So what happens? Number 0 has an error. Thank you, Shukriya. Say again?
Acknowledgement of 0.
Exactly. So we'll send back, the receiver will send back acknowledgement 0 to say, hey, there's something wrong. So remember, looking on the line number 0, 1, 2, 3, all the way to 100, and then 101, 2, up until 127, and then the next number 0, 1, 2, 3. So this guy, the sender, is going to send all the way up to number 99. It's waiting to send number 100. The acknowledgement 0, it tells us, what does it say to it? It says go back to number 0 and start again. That's why they call this go back n. Go back to this number. N means number. Go back to number 0 and start transmitting again. But what happens to number 1 and 2 and 3? Discard. Why? They're perfect frames. What's wrong with them? They're corrected. They have no errors.
The sequence is not correct.
Pardon?
Sequence.
Out of sequence. It's called out of sequence. We're waiting for frame 0, but we got 1. We're waiting for frame 0, we got 2. So discard, discard, discard. So even though there's nothing wrong with them, we check them all for errors, they're perfect. It took a long time to transmit them, a long time to check them for errors, but we discarded them. And this guy here got number acknowledgement 0. What does acknowledgement 0 do? What does the sender do again after receiving acknowledgement 0?
Send the copies of all those.
Say again?
You send the copies of.
Sender will send copies of all those.
Send them all again. 0, 1, 2, 3, all the way to 99. And that's such a waste to the transmission channel. You are sending 100 frames, and every frame is probably 2,000 or 4,000 bytes long. And they were sent and transmitted correctly, and they were received correctly, except they were out of sequence. So this is one disadvantage of this system. Go back in. Sometimes you retransmit good frames that were already transmitted perfectly and took kind of enough time to transmit them and retransmit them again, especially with very large window size. So that's a disadvantage. That does not utilize the channel correctly or nicely. It does not use it correctly. It kind of abuses the channel. Retransmit already frames that have already been correctly transmitted, retransmit them again. But that's how the protocol works. And that's the disadvantage of this system. So years later, they improved this system and they got a new system. And the new system, what is it called? The new system works like this. It's called the selective, remember the last one is called the go back in. This is called the selective reject or selective repeat or reject, whichever one you want to call. So in some textbooks they call it the selective repeat, in some they call it the selective reject. That means don't reject all the frames. Selectively reject the bad ones and keep the good ones. That's what it means. So, how does this work? This is an improvement to the go back in. So this is how it works. Let's go back. Let's have an example. Window size equals, let's say 5. Hey, what's your name? Did you sign your attendance? Have you checked in? It's already there, it's running, so run your app or something. Okay, but before you do your app, we've selected window size 5. What does window size 5 mean?
That's the total amount of source.
That's the total amount that can be sent. Wrong. Now that's better, yeah. That's the maximum number of unacknowledged frames.
Yeah.
That's not the window size. Thank you. Right, so, and then we have modulo 7. What does modulo 7 mean? Modulo 8, I beg your pardon.
Modulo 8 means like that's you can send from like 0 to 8 or 7.
0 to 7. Modulo 8 is used, it means the sequence number, so the range of sequence numbers we use will have 8 numbers, modulo 8, from 0 to 7. If we were using modulo 1 to 8, it means it will have a total of 128 numbers, from 0 to 127. Okay, so this one, it will use 0 to 7, and then back again to 0, 1, 2, 3, all the way to 7, and so on. So now, the sender will send, how many frames will the sender send in this system? 5 frames, the window size is 5. What are the frame numbers that you would allocate to those 5 frames? 0, 1,
2, 3, 4.
Okay, and what else do you do as a sender, if you are the sender here? Keep copies first of those 5 frames, 0, 1, 2, 3, 4, and start a timer for each of those frames as you send it. Timer 0, timer 1, timer for frame number 2, 3, and 4. So it's pretty much similar to the go back in. But here's the difference. Now let's say here we got frame 0, 1, 2, 3, and 4. Number 0 has a problem. Now let's say number 3 has a problem. But number 2, 1 and 2 and 4 are okay. What do we do in this system? Can we send frame number 1 to our user to watch the video starting at the second frame? It doesn't work. You can't start, if you're watching a movie or you're downloading a book, you don't want to write the second page before the first page, before page 0, so it doesn't work. So, first, frame number 0 has a problem. So first you discard that. Okay, it has an error. It's discarded and you immediately send an acknowledgement. But this time, this system, they don't call it an acknowledgement. They call it negative acknowledgement, NAC. With the exact number, not the next number. This is negative acknowledgement, means I did not receive this frame correctly. Please send me only this frame. That's what the negative acknowledgement means. Right. What does acknowledgement 0 mean? Okay. Going back to our older system. Acknowledgement. What does acknowledgement 0 mean? What does acknowledgement 0 mean? Okay,
It receives
or,
all before 0.
and everything before 0 is acknowledged. What, such as, what number could be before 0? 7. Depends on the modulo, but normally if it's modulo 8, then the number before 0 is 7. Like you send 1, 2, 3, 4, 5, 6, 7, 0. So if I send you acknowledgement 0, that means I've received everything before 0, which could be 7. Okay, and it also could mean that the next frame I expect to receive from you is 0. And it could also mean there's something wrong with frame 0, 2, 3, 7. They all mean the same thing. They don't really have a conflict. I'm still waiting on frame 0. But that's not what we are sending. Now, we're not sending acknowledgement, we're sending negative acknowledgement. So there's a difference between acknowledgement 0 and negative acknowledgement. Acknowledgement 0 means I've received everything before 0, I have not received 0. But negative acknowledgement, you just say, this one has a problem, send it. That's all. A negative acknowledgement only refers to one frame only. So the first frame has a problem. So we send negative acknowledgement. Now we look at the next frame. The next frame is perfect. But remember, it's not in the right sequence. We cannot send it to our user. Now, we have to save it. We have to keep it until we receive frame number 0. This is the new protocol. This is called the selective reject. We selectively rejected number 0, but we don't reject number 1. So what we do, we keep number 1. We save it. We hold on to it. We cannot send it to our user. Why? Because it's not the right sequence to send to our user. But we need to hold on to it. So I'll put down here hold. What about number 2? Number 2 is also good. So let's hold it. What about number 3? Number 3 has a problem. What do we do with it in this new system? We send negative acknowledgement. So we send a separate negative acknowledgement. Remember, the NAC only refers to one frame. You can't send two frames that have problem in one negative acknowledgement. Each one of them has its own negative acknowledgement. This is negative acknowledgement 3. That means there's something wrong with frame 3. Please send me frame number 3. Now let's finish with this one. And of course we discard it here. We don't keep the frame number 3. Now, but frame number 4 is good. What do we do with it? We hold it. So frame number 4, we hold frame number 4. Hold it in memory. So now we need memory in this system at the receiver end. Now, negative acknowledgement 0 means this frame has a problem. I have a copy of it. I'll resend it. So when I receive this, I'll send this back. Remember, these arrows, guys, if you draw them, make sure they are slanted downward, because this is time. Like, this is time in milliseconds or whatever it is. So if you send me a frame at this time, don't have it arriving at an earlier time. If you send it, it will arrive a little bit later. So this is time-wise. So time is always going. If you start sending, it will be received a little bit later, not earlier. Anyway, so this guy will send frame 0. It will also immediately will receive and will restart timer 0. And then it will receive frame 3, or negative 3, so it will send a copy of frame 3 and start timer for frame 3. Now this guy receives now frame 0. Are you with me here, guys? So we got frame number 0. What happens? What do we do with it? We check it. Let's say this time it has no errors. Perfect. So what do we do with it? It's okay, and can we send it to the user? Yeah, that's the one missing frame that needs to go to the user first. So we send this to the user, and this will be followed by frame number 1 that's already waiting to go to the user, and then followed by frame number 2, but frame number 3 is missing, and we cannot send number 4. So that's it. So frames number 0, 1, and 2 are going to the user. Now, frame number 3 arrives. We check it, and if it's perfect and it's good, then we also, that's the next frame that needs to go to the user. And then number 4 will follow it. And now we've sent 0, 1, 2, 3, and 4 to the user. Now we can send back acknowledgement. What acknowledgement shall we send to the receiver, to the sender?
5.
What do you think? 5. That's why, because what does acknowledgement 5 mean? What does acknowledgement 5 mean? Now, we send to the sender acknowledgement 5. That's not negative acknowledgement. What does acknowledgement 5 mean? Does it mean we have received number 5? We've received everything before 5. We're acknowledging number 4. But also, it means we're waiting for number 5. So acknowledgement only means at least these 2 things. Maybe more, but for now, anytime you receive any acknowledgement with any number, that means you are acknowledging the number before it, and we are waiting for this. Okay, so acknowledgement 5 means we have received up until number 4 perfectly, all of them up until number 4, and we are waiting for number 5. And when the receiver or when the sender receives acknowledgement 5, what does it do with the frames it has on the timers? It turns all the frames, the timers off, and removes all the frames up until number 4, remove them off memory. We no longer need them in memory, and now it will go and send the next few frames. What frame numbers will the sender send now, after receiving acknowledgement 5? 5, 6, and 7, right? Pardon?
0, 1.
Yeah, and what else will it do after sending the frames? It will keep copies of those frames. Don't forget that. You forget that, you lose a lot of marks. And what else does it do? It starts a timer. Timer 5, timer 6, timer for each frame. And so what happened here is that with this system, we didn't have to retransmit frames, the good frames that were sent first time. Imagine if we have window size 100. Window size 100, that we are using modulo 128. And we start this sender. What will the sender send? This is the sender, this is the receiver. Somebody from the back row there, yeah, please. What frame numbers? We have now a new sender and receiver, and the window size is 100. This is using selective repeat, and we're sending new frames. What frame numbers shall the sender send?
0, 1, 99.
0, 1, 2, all the way to 99. And keep copies of those, all those frames. 0, 1, 2, 3, all the way to 99. And get timer 0, timer 1, timer 2, and so on. And the receiver receives all these frames from 0 to number 99. 1, 2, 3, all the way to 99. 100 frames, they're all received. There's something wrong with frame number 0, but the rest of them are all perfect. What happens here? Guys, any of you can tell me what happens? You're doing something else? What do you think will happen?
Thanks for acknowledgement.
Pardon?
Acknowledgement.
You send back acknowledgement. What acknowledgement number will it send?
0.
What kind of an acknowledgement? What's the name of the acknowledgement? Yeah, it's acknowledgement 0, is it? Negative acknowledgement. It's NAC, not ACK. It's negative acknowledgement, number 0. And what do we do with frame 0 here?
We discard it.
Discard it. What do we do with frame number 1? Hold. Frame number 1, 2, 3, 4, all the way to 99. All the other 99 frames are kept hold in memory. And then this guy here, what happens to the sender? The sender got NAC 0. What does the sender do?
0.
Sends frame number 0 and restarts its timer. Right, and then the receiver receives frame number 0. What happens here?
Then it sends the user, and then all over will.
Exactly. Send frame 0 to the user, followed by frame number 1, 2, 3 that we have in memory. We have kept all those 99 frames in memory. And then at the end, we send back what? What do we send back? Another negative? What does the receiver send back? Acknowledgement. What number is the acknowledgement?
100.
100. That means the receiver knows, then the sender knows all frames up until 99 were received. We no longer need to keep them, get rid of them in memory, and send the next 100 frames starting at 100. What frame numbers will the sender send?
101.
100. Up until 127, and then 0, 1, 2, 3, and we send 100 different frames. Okay, so what's the advantage of this selective reject? What advantage did it give us? That when we sent 100 good frames, because the first frame was bad, we didn't have to resend them again. We kept them in the receiver's memory. We only sent frame number 0. If you look at earlier on, this is the selective reject, but earlier on when we did the same operation with the go back in, we sent 100 frames and number 0 had a problem. We rejected them all. The rest of them, they're all discarded because they're the wrong sequence number. And this guy had to send them all again, 0, 1, 2, 3, all the way to 99. So this newer system, the selective repeat, if you transmit a good frame, we never discard it. We keep it in the memory until you send us the missing one. So it uses the transmission channel a lot better. It's better at utilizing. We don't retransmit good frames using the selective reject. With the go back in, the older system, sometimes you might have to retransmit good frames. So which one is better? The selective reject or the go back in? Come on, guys. You really went for the selective reject, right? Okay, why is the selective reject better? Or why is the go back in better?
Selective repeat is way better because it doesn't have, like, the sender will not have to send all the frames again. Only the ones which are.
So the channel will not be wasted by sending good frames again. Good copies or copies of the good frames again. We only send the bad frames. So it has better channel utilization.
For selective repeat, you have to use more memory. Like receiver side.
We need more memory on receiver side.
But the downside is that we need memory. See, you don't have to send them. You don't have to send them again, but it means you have to keep them in memory at the data link layer. So you need a lot of memory at the data link layer. How much memory do we need at the data link layer?
Equals to.
How much memory do you think you need? See here, the first time we had window size 5. You receive 5 frames. Frame 0 was bad. We discarded it, but we kept the other 4. We have to keep them in memory. This example here, we had window size 100. We received 100 frames. But the first frame, the worst situation when the first frame is bad, we discarded it, but we kept the other 99 frames. So how much memory do we need? Can you figure out?
Equals to window size.
Yes. Window size minus 1. So if I ask how much memory does the receiver require in this example, or in all systems, how much memory is needed? It's whatever the agreed window size minus 1. And how much memory does the sender need? How much memory does the sender need?
Same memory size used to having like in
Give me figure.
So exactly what the window size?
Whatever the window size for the sender. So the sender needs as much as the window size of frames, right? Not the window size, say 5, that means you need 5 pi. No, you need 5 spaces of frames. So it's 5 multiplied by the frame size. So if every frame size, the maximum frame size is 4,000, then 5 times 4,000. So we need whatever memory required to hold 5 frames, so the window size of frames. So the sender needs a window size of frames. If the window size is 5, then it must have enough memory to hold 5 frames. And the receiver, in that case, needs whatever is required to hold 4 frames. Window size minus 1. Because the worst situation is if they're all good except the first one. That's the worst situation. You must keep them all except the first one. And that's window size minus 1. Break time, is it?
Yeah.
Yes. Woohoo! Let's go. Okay, I'm going to switch off the attendance, so make sure